Hello, and this is a question from an old C2 paper, and this one is about a volume, and we have a show that it turns into a cubic, and then there's some calculus, and then there's some maximum. So it's all about applied calculus, if you like. First thing I'll say is, if you can't do the show that, you use this in parts B and C, so you can still get more points than you'd lose here if you carry on. So don't sort of stop here, I can't do this, and then not carry on. If you can't do the show that, you can use what they've just shown. That's why they write them as a show that, so that you're not losing everything. Show that can be tricky. You just have to have the experience to know how to get started, really. Here we've got a block. It tells us the surface area of it, and we want to know the volume. Now, the problem with the volume is, you have a sneaky peek at what they're aiming for. You shouldn't start with this. This should be the final answer, so we've got to start somewhere else. But it's always useful to have a sneaky peek. Look, it's all in x's. The volume should be just this times this times this, yes, times the three lengths together. But that would put a y in it, and we haven't got a y. So I think that's what the trick here is going to be. We can write this as v equals 2x squared y, but we've got to get rid of that y, and that's where it's going to get all this from. And how we're going to get rid of the y? Well, we're going to do that with this total surface area. So surface area is the area of this face, which is 2xy, plus the area of this face, which is 2x squared, and the area of this face, which is xy, all added up, and everything doubled. So I'm going to just double everything now, turn these into 4, and put a 2 there. You add all that up, and it equals 600. So now we need to replace the y that's in here. We need to replace this y, with the y's here. So we need to do some rearranging. So let's look at this guy again. 600 equals. So we've got 4xy here and 2xy. So that's actually 6xy. We can cancel that straight away. Plus 4x squared. Okay, so we can just very straightforward to rearrange this and say that 600 minus 4x squared all over, just sneak it in, 6x equals y. And we can then substitute that into here, and when you expand it, yes, you're going to then times that whole fraction by the 2xy. If you expand that, you've got 600 over 6x, that's going to give you 100, 2, that's going to give you the 200, x squared over x is your single x. And then here you've got 4x squared over 6x. Well, that's going to give you a single x times x squared, that's your x cubed, and your 4/3 is going to come from that 4, 2, and 6. So pretty happy that's going to come out in the wash. I'm not going to go any further. I'm going to let you finish that off. Make sure you can follow the algebra through. Once we've got that, so get rid of everything there. Once you've got that and you've shown it for your 4 marks, we can now use it. Use calculus to find the maximum value of v. Well, it's a cubic, so a cubic is going to look like this. It's actually a negative on the cubic bit, so it's actually going to look like this. And the maximum is this bit here. And a stationary point, where the turning point and stationary point is where the gradient equals 0. So use calculus, differentiation, to find the maximum value when the gradient equals 0. So we're just going to do dv by dx and differentiate it, which is going to times the front by the power, which just times by 1, reduce the power, that goes away. Times the front by the power is going to cancel the 3's. If we times that by 3, so it's just minus 4, and reduce the power by 1, so it's squared. And if we make this equal to 0, to find that maximum, we'll get two answers, of course. We'll get two answers because there's a quadratic here. One will be the answer for this one and one will be for this one. Now, because I've drawn out the shape correctly, I'll know that whichever one is bigger, the bigger answer will be my maximum because of just the way that the shape is of the cubic. But if you weren't sure, you can always, well, in fact, it asks us to justify the fact that the one we found is the maximum. Well, we'll differentiate it again is the good trick for that. So if we do d2v by dx squared, that goes away. We multiply that by 2, so we get minus 8x. And then whatever you've said your value for part B is, let's say it was 7, then minus 8 times 7 is a negative number. If d2v by dx squared comes out as negative, then you've got a maximum. If it comes out as positive, then you've got a minimum. The other way you can do it, if you don't like differentiating again, is if, let's say we said this was 7, I'm just making this up, you need to actually make that equal to 0 and work out what the value is, then you could work out the gradient of 6.9 just by substituting 6.9 in here, and 7.1. And if this 6.9 is a positive gradient and this 7.1 gives a negative gradient, it must be a maximum. And if it's the other way around and this is a negative gradient and that's a positive gradient, then you know it's a minimum. So there's two ways of doing that. So again, I won't go any further. If you understand what I've been saying, you should be able to do the actual algebra now, the rearranging, the solving and checking. The fact it says justify means it should be a maximum, and you can ask for the maximum there, so make sure that on this part B you do pick the correct of the two answers from your quadratic. If you have any further questions about that, then pop them in the comments below. Otherwise, ta-ra for now.